Hello students, today we will be continuing with our chapter Surface Finish from the subject Engineering Metrology. In the previous lecture, we have studied what is surface roughness, what are the factors causing surface roughness. Today we will be learning some terminologies or some terms related to the chapter Surface Finish. So let's begin with the chapter Primary and Secondary Texture. Now today we will be learning what is primary texture and what is secondary texture. So let us begin. Primary texture. Primary texture is also known as roughness. So what is primary texture? Surface irregularities of small wavelength are called as primary texture. So basically the irregularities which are of smaller wavelength are called as primary texture. As you can see in this figure, this surface is having irregularities in the form of hills and valleys. That is this. You can see these hills and valleys. So these hills and valleys which are of smaller wavelength, that is the distance between the two irregularities is very small, are known as primary texture or roughness. Now what is wavelength? From this figure you can see this is the first peak and this is the valley. Again this is the peak, this is the valley. So the distance between two successive valleys or the distance between two successive peaks is known as the wavelength. So in this case you can see for this surface the wavelength is very small, or we can say that the irregularities are closely spaced. So these irregularities is nothing but the primary texture or roughness. So the primary texture of the roughness is represented by these projections, that is smaller projections. Now primary texture are also called as microgeometrical errors. Now why they are called as microgeometrical errors? Because they are very small. Now why primary texture or roughness is caused? What is the reason for it? Now primary texture includes irregularities caused by direct action of cutting tools on the raw materials. So primary texture or roughness is basically the result of the direct action of the cutting tool on the raw material, such as irregularities of the third order and irregularities of the fourth order. Now what are irregularities of third order? These include feed marks of cutting tools. So the irregularities which are caused due to the marks of the cutting tool on the workpiece are known as irregularities of the third order, whereas the irregularities which are caused due to the rupture of the material. For example, if you are machining a workpiece and during the machining some amount of material is removed from the workpiece, and during that removal process, or we can say rupture of the material, we get irregularities, and that irregularities are nothing but known as irregularities of the fourth order. So primary texture is called as roughness and it includes irregularities of third order and irregularities of the fourth order. So this is nothing but on this figure where we can see hills and valleys, and the spacing between the hills and valleys is very small, that is the wavelength is very small, is nothing but the primary texture. Now we will see secondary texture. Surface irregularities of larger wavelength of a periodic character are called as secondary texture or waviness. So we have seen that primary texture roughness is basically the irregularities of smaller wavelength, but when we consider the irregularities of the larger wavelength which are periodic in character, that is they are repetitive, then they are called as secondary texture or waviness. Now you can see this figure is nothing but represents the secondary texture. Now for this surface, first irregularities are in the form of small projections. So these are nothing but the primary texture or roughness. But if you consider the overall length of the workpiece, you can see that this pattern of the small projection is repeating again and again. First you can see from here it goes up and then it goes down. Again from here the irregularities go up and then again come down. So here you can see a wave is formed like this. Here we can see, here we have the peak, here we have the valley. So the irregularities which are of larger wavelength. Now why it is called as larger wavelength? Because the distance between the successive hills or the successive valleys is quite large compared to the primary texture. So surface irregularities of larger wavelength of periodic character are known as secondary texture or waviness. They are also called as macrogeometrical errors since the wavelength is large compared to the primary texture. Now why is secondary texture caused? It includes irregularities of first order, such as irregularities due to lack of straightness of guideways of tool, deformation of work under cutting forces. So, if there is irregularity or the lack of straightness of the guideways of the cutting tool, it will result into the irregularity of the first order. Similarly, it includes irregularities of the second order, that is irregularities caused due to the vibrations. So when there is vibration in the machine, it will ultimately lead to the vibration of the cutting tool, and due to the vibrations, it will result into secondary texture or irregularities. So primary texture is nothing but the irregularities of smaller wavelength, whereas secondary texture are nothing but the irregularities of the larger wavelength. Primary texture is also called as microgeometrical errors, as the distance or the wavelength is very small, whereas secondary texture is called as macrogeometrical error since the wavelength is large compared to the primary texture. Then in primary texture, the irregularities are of third order and fourth order, whereas in secondary texture the irregularities are of first order and of second order. That is, irregularities of the first order include the irregularities due to lack of straightness of guideways of the tool. That is, if the guideways on which the tool is mounted is not straight, then it will result into irregularities on the surface of the workpiece. Similarly, sometimes while cutting, the workpiece gets deformed due to the action of the cutting tool or the due to cutting forces on the workpiece, and due to this deformation we get irregularities, and such type of irregularities are nothing but called as secondary texture. Now we will learn different methods of measuring primary texture or roughness. Now, what are the different methods used? The following are the methods used for measuring primary texture, roughness of a surface. Now, the methods are listed below. First is the 10-point height method, which will give the value as RZ. Second is RMS value, that is root mean square value. And the third is center line average method or CLA value. These all three methods are used to determine the value of the primary texture or the roughness. Now let us study these methods one by one. 10-point height method or RZ. Now how to determine the roughness value RZ by using 10-point height method. Now first we will see this profile. You can see in this profile there are many ups and downs in the value of in the form of hills and valleys, and this represents the profile of the workpiece under study. That is, we have taken a sample of the workpiece for which we have to determine the surface roughness. So the length which is under study is known as the sampling length. Students, for determining the roughness, we never take the entire workpiece length. We should select a suitable length of the workpiece, and over that we will carry out the study. That is, we will find the value of the surface roughness, and the length of the workpiece selected for our study is nothing but the sampling length. So in this sampling length we can see this projection, that is in the form of hills and valleys. Now in 10-point height method we will select 5 hills and 5 valleys which are highest and which are lowest. So RZ value is defined as the average difference between 5 highest peaks and 5 lowest valleys of the surface texture. So this is my surface texture or the surface. Now on this surface, first we will determine the 5 highest peaks. Now from the figure you can see the first highest peak is denoted by distance R1. So this is the distance R1 of the first highest peak. Then second highest peak is R3. Then next the third highest peak is R5, next R7, and next R9. Similarly, lowest peaks are R2, R4, R6, R8 and R10. So basically for this method we have to determine the distance or the height of the 5 highest peaks over the sampling length, and then we will determine the height of the 5 lowest peaks of the sampling length. Now this height is determined from a reference line which is parallel to the mean line. So for determining the height we will create a first a reference line. This is the reference line, and from this reference line we will determine the heights of the highest peaks and the highest values. Now after determining the heights we will find the average of the difference between the 5 highest peaks and the 5 lowest valleys. You can see, so average of the 5 highest peaks, that is R1 plus R3 plus R5 plus R7 plus R9 divided by 5. So this value, that is R1 plus R3 plus R5 plus R7 plus R9 divided by 5, will give the average value of the highest peaks. Whereas the second, that is R2 plus R4 plus R6 plus R8 plus R10 divided by 5, will give the average of the 5 lowest peaks, lowest valleys. And when we will find out the difference of both these average, that is the average of the 5 highest peak values and the average of the 5 lowest valleys, then the value that we will get is nothing but the RZ value, or the roughness value. So RZ is defined as the average difference between the 5 highest peaks and 5 lowest valleys of the surface texture within sampling length, measured from a reference line which is not crossing the profile but parallel to the mean line. Now you can see in this figure that this reference line is not cutting the profile anywhere. For example, if we pass this reference line from here, from this point to this point, then it will cut the profile. But in this case, the reference line should not be passing through the profile. That is, it should be parallel to the mean line but not passing through the profile. So this is my reference line. So first we will determine the distances, and then we will find the average of the difference between the highest peaks and the highest valleys, lowest valleys. And finally the value that we will get is nothing but the value of the surface roughness.